Okay, this is TEAS mock math version 4. So you should have your mock test done, and then you should get your answers, be able to key it and find out where you are score-wise, and then be able to tie back to each of your classes from here. So in the left margin, as usual, I will put what class the problem comes from. I've already worked these out because I always try to check and make sure that I have all the right answers there, because inevitably something always ends up not being there that's supposed to. So I'm going to kind of do the work quickly, because I know that a lot of you, especially by the time you get to the 4th and the 5th mock, you mostly want to check your answers because you're mostly going to be okay on them. So I will do an explanation and I will write my work. If you need to see something again, you can always back the video up 15 seconds or however long I'm explaining the problem so that you can pause and see the work more clearly. So if I'm going really fast and you think your work lines up, but you want to make sure, or you discover that you get it wrong and you're not sure why, you can back up with the 15-second feature that YouTube has and pause it so that you can see all the work that's on the screen. My main focus here will be to get through this pretty quick so that the ones that you're getting right, you are seeing what the work is, but you're moving on fairly quickly, allowing you hopefully enough time to do more mock testing as opposed to less. This first one is from fundamentals class. I'll be abbreviating that as fun. This is from the FDP section of fundamentals, fraction, decimal, and percent conversions. This is one of several things that we talk about there. So there we talk about converting between those three number forms, fractions, decimals, and percentages. We talk about putting lists of numbers in order as rational number sets. And this is kind of a step down from that. So this is a little bit easier than that, just asking which number is the smallest. In this case, you are going to want to change these to decimals. It is very hard to compare fractions, even if you're fairly good at fractions. It's very easy to compare decimals because you're basically able to ignore the fact that they're partial numbers and treat them as just whole numbers. Before I did this, before I went to put them into decimal form, I went through and took out two sets of numbers that are improper or mixed. So an improper or mixed will always be bigger in numerical quantity than a proper fraction. We're trying to get the smallest, so I can glance at this number list and tell you that the first one, which is 7 1/3, and the third one, which is 8/7, cannot be the smallest because they are flipped upside down compared to the ones that are going to be smaller. That leaves me with 1/3, 6/7, and 9/10. With these not having the same denominator, the best plan is going to be to turn them into decimals so that you can really see them and compare them. Needless to say, having two decimal places each is going to be the best way to do this because it's hard to compare. For example, if I had that as 0.9 or I had this as 0.860, it would be much harder to compare quantities. If you put them all in two decimal places, you can easily compare 33 versus 86 versus 90. So of course, that's going to put 1/3 as being the one that is the smallest. The second question is an averages question. So that is also from fundamentals. A medication expired 4 years ago. The medication was originally 600 milligrams and is now reduced to the strength of about 200 milligrams. We can infer that it lost how many milligrams per year? So the first thing we need to do is find out how much was actually lost, because what we know is how much we originally had and then how much we now have. So this means that if you take the two and subtract them, 400 milligrams was lost over the 4 years. They want to know how much per year, and there were 4 years in total. So we're going to divide the 400 by 4, and that's going to give us 100 milligrams per year. That's averaging because we're averaging over 4 years with a total loss that belongs to that 4 years, and that's going to be B. 3 is also from fundamentals, is also an averages question. The only trick to 3, really, most of you are probably doing very well on averages, is that they gave the first score up there, and then they gave all the other ones together. So the only thing that might have happened in error is you might have missed that 93. There are 2 93s as well. And there should be a total of 5 numbers. So you're going to add those 5 numbers up. Then after you add those 5 numbers up, you will divide by 5. This does say round answer to the nearest whole percent. The answer that I got was 89.8. So that's going to round up to 90, not down to 89. The nearest whole percent is going to be to round up because that's an 8. Number 4 is from algebra. This is a 2-step equation. And essentially what we have, we're going to rewrite it so that it's not confusing where they have the x equals with the question mark. All they really are trying to say is solve this equation just like you've been doing in class. The first thing I'm going to do is add 4. That's going to give me 4x equals 24, and then I can divide by 4 and find out that x is 6, which is C. This is also from algebra number 5. This is evaluating expressions. If you are ever going to take the HESI, evaluating expressions is quite a bit more prominent in HESI than it is in TEAS, but you could have one of these. It will be relatively simple like this. This also ties into fundamentals because when you get this all plugged in, so you've got a value for C and a value for Z, and they occur potentially multiple times. So you got 2 plus 3 times 10 times 4 times 2. So when you get it all filled in, it looks like this. Then order of operations kicks in a major way. So then we have to be really careful about the order that we're going in, and that's where I'm saying it ties into fundamentals. So the first thing in order of operations is things that are inside parentheses, and we don't have anything like that. This does not count because there's not an operation in the parenthesis. It's just saying 3 times 10. So that is considered multiplication. There is nothing in parentheses that can be solved. There's nothing in exponents. So the first step is going to be multiplication. You're going to do this multiplication here and that one there because those are for simplification. So those need to be done very first. 3 times 10 is 30 and 4 times 2 is 8. Now we can fill in the 2, the plus sign, and the other times sign. Now we still have multiplication. So we're still going to want to do this part here before we go on and we add the 2 because we're still in this step. So 30 times 8 is 240. So what we wind up with is 2 plus 240, which is 242, and that is choice B. So be very careful if you're evaluating that you are following order of ops. So multiplication is going to be the first function. It's going to be what you're doing until you get through everything that's multiplication. Always do a simplifying multiplication function first, then one that spans more of the equation. 6 is also algebra. It is a multi-step equation. So we've seen 3 problems in a row that are algebra, but they're all different types. So this is multi-step equations. And this one has some negatives. So a lot of the multi-step equations that you see are going to be made a little more complicated by the fact that they have negatives that could potentially cancel. The first step here is to distribute. So negative 2 times 2 is negative 4x. Negative 2 times negative 5 becomes positive 10, so plus 10. Then we can bring the rest of the equation that we're not using yet on down. And then these two, so we're going to combine like terms before we try to cross the equal sign. When we combine a 10 and a negative 10, that just goes away. So now we've simplified to negative 4x equals 3x plus 4. Now I can put my x's together on the left-hand side, which is negative 7x equals 4. And the last step will be to divide that negative 7 off. This says 4 over -7. So only one of those two numbers is negative. That's going to mean that the whole fraction is negative, because ultimately, if you were to actually carry out the fraction operation, you'd have a positive divided by a negative, which would then be a negative. So that ties into fundamentals there. When you see something that looks like that, that would cancel out and it would become positive. If you see something that looks like this, or oppositely like it looked here, you have one negative and one positive. One negative with one positive will cause the whole thing to be negative. So that's going to be A, -4 over 7. Number 7 is also algebra, also multi-step. It's actually a step down in difficulty from what we just did, because we don't have so much cancellation happening. So you got 4x plus 10 equals 2x plus 16. The first thing I'm going to do is go over here and subtract 2x. So now I've got 2x plus 10 equals 16. Subtract 10. Now I've got 2x equals 6. And when I divide by 3, I get that x equals 2. So number 8 comes from percent applications class. And this is, so anytime that you see you're dealing with a percentage word problem, it's a very good idea to pretty much instantly identify what scenario it's in. Of course, there are some problems that are in multiple scenarios. You're going to do something that's one scenario and then something that's another, but a lot of them do just have one. This one is just scenario 4. Remember that scenario 4 is percent difference. So what they're telling you is, here's the price something used to be. Here's the price that it now is. What is the percentage by which it's being discounted? So this is going to be difference over original. Percent difference is always difference over original. So the difference between the two is obtained by taking 50 minus 40, which equals 10, and then dividing that by the original number, which would be the normal price that you would pay for this shirt. So that gives us 10 divided by 50, which comes out to 0.2, and that translates to 20%. Number 9 is also percent apps. At first glance, it might look like it's a scenario 4, but it's not. We still are talking about shirts and discounts and a lot of the things that we talked about in number 8. But this one is essentially saying you're buying 2 shirts. They're 40 each. Your purchase will be discounted by 10%, and then you'll pay this percentage of tax. So these are, some people are overwhelmed by these. There's absolutely no reason to be overwhelmed by these. All you have to do with these is just start from the beginning, figure out what you know, and then put everything in order. There's really only one order that's logical for this. The first thing you want to do is not be using a 40 because we're buying 2 shirts. So if we're buying 2 shirts, what we need to know is, what would the normal full everyday price of these 2 shirts be? And that's 2 times 40. So $80 is what these 2 shirts together would normally be. Then we can do our discount of 10%. So then that's a scenario 3, where we take 80 times 0.1, and we find out that the discount amount is $8. So $80 and saving $8 means that now with this 10% discount, the 2 shirts together is now $72. The last thing we need to do is apply the sales tax to that. Sales tax is taken from the final discounted price. So you'll take 72. You'll multiply 72 times 0.06 to get the amount that's taxed. That is $4.32 in tax. It always helps to write what you're finding out in words. So as we went along in the problem, the first calculation we did was normal price for 2 shirts. Then we found out how much you're saving because of a discount. Then you're finding out how much your purchase is because of the discount. Then you're finding out how much tax. And now you just have one more step, which is to take the 72 plus 432. And that is 7632 is the total. Of course, on something this complicated, always check and make sure that that is actually what the question is and that it's not something weird, like how much change would you get for a $100 bill? This does say what is the exact total that he is spending, and that is what you get when you add those last two things together. Always check what the question says. It sounds really simple, and you've probably gotten used to doing it to where you really don't think about it, but always double check. The more complicated it is, the easier it is for them to sneak something past you. So just make sure that you are truly addressing the question. 10 works in a very similar way. 10 is also percent apps. It is also scenario 3, and both 9 and 10 have in common that they're not only percent apps scenario 3, but they have like multiple scenario 3 steps. So you wind up doing scenario 3 over and over again throughout the same problem. This one, you have a laptop that's normally $850. It's 15% off. Sales tax is 7%. Very similar process. So the first thing I did is took the 850 and multiplied it by 0.15 to find out what the discount is. So you're going to get $127.50 off because of this 15% discount. Then I would need to know what the new total is once I do get to save that amount. So then I take 850 minus 127.50, and I find out that my new cost is $722.50. So this is my new cost. The last thing that I need to do is apply that 7% sales tax. So now I'm going to take my new cost times 0.07% sales tax, and what I get is $50.58 in tax. So I want to take my discounted price and I want to add my tax. So $722.50 plus 58, and that is going to equal $773.08. And again, double check the question. Make sure there's not something weird. Actually, in this one, there is something weird. So it says, if the laptop normally sells for this and sales tax is at a rate of this, how much will she pay in sales tax? So that's how easy it is for them to sneak that in there. I literally am the one who wrote that, and I almost missed that because I have circled the cost with tax. The answer is there, but it's up here in A because this was actually their final question. So always go back and check every time I do a problem, no matter what kind of problem it is, no matter how complicated. I always go back to the question mark before I make my final click to the next page. I go to the question mark. I read the part that goes right before the question mark that asks the actual final question, and I make sure that I am in line with what that was supposed to be. In this case, I would have gotten it wrong because I would have chosen C and moved on, except I did check, and what do you know? They want sales tax. So always check that. It gives you one more final chance to make sure you don't miss a point just for misreading. Many of you that do this program score very, very high in math. My average student is pretty well into the 90s in math because you're using these strategies, and it really makes the whole thing easy. The points that my students do miss are things like that. And if I miss a question on the math, which I typically don't, but once in a long while, I'll miss one question and it's something that I misread. So you can always avoid that by just, before you move on, just read what they actually asked without all the noise of all the things they told you and described and all the numbers they gave you and all that stuff, just the question. And then you can make sure that what you did answered the question. 11 is a ratio and proportion problem. This is one of the advanced proportions. It has a conversion that happens after we set up the proportion itself. So this is one of the ones with sugar and people, which is a really common one. You're always going to start a proportion with words so that you know what you're actually comparing. So in this case, we're comparing cups of sugar to people. The first half of our proportion is given to us as 2 cups of sugar to 50 people. We want to know about 500 people, so we can fill in people on the second half. We don't know how many cups of sugar we would need for 500 people. All we know is that we need 2 cups if it's 50 people, and we know that we're trying to serve 500. This particular question does not ask for cups. It actually asks for bags. How many bags of sugar do you need? But this proportion can only be solved with cups because the info that they gave you, the things that you have that you can plug in, is cups and people. So we're going to solve this, get the quantity of cups, and then turn that into bags. So when I do the, excuse me, cross multiplication and division, I get x equals 20 cups. So 20 cups of sugar would serve 500 people. They then mentioned to us, let me erase some of my extra writing here, that sugar is sold in bags that have 6 cups each. Ultimately, the question is, how many bags do I need with these 500 people? So I'm going to take the 20 and I'm going to divide it by 6, and that does not come out evenly. It comes out as 3.33. And remember that that number is a quantity of bags. If we need truly to serve 500 people, and we need 3.33 bags of sugar to do that, we have to buy 4 bags. Last I checked, stores won't let you buy a third of a bag of sugar. If they have it sold as a bag, you either buy the bag or you don't. And you can't buy 3 bags because you'll be missing a third of a cup of sugar, and that would throw off the recipe probably quite a bit. So you have to round this up. This is something I've been talking about a lot lately. Discrete quantities are quantities that must be even. You can't buy part of a bag of sugar. You can't have part of a person. As you'll see a little bit later, you can't have a partial trailer that hauls something. You either have a trailer or you don't. So always factor that in. If you see a decimal, glance at your answer choices and glance back up to the question, not only to make sure you've answered the question, but also to make sure that you have factored in the possibility that you need to just round something up. 12 is just considered a word problem. This is the type of thing we did in fundamentals. It'll look like a proportion at first. This one is actually simpler if you just solve it as a regular word problem. So you're making fruit plates for a party. You do 3 pieces of cantaloupe and 4 pieces of watermelon per plate. 13 guests are coming, and what we want to know is if each of those guests does 1 plate containing these components up here, how many pieces of watermelon will there be in total? So basically you have 13 guests times 4 pieces of watermelon each, and that's going to be 52 pieces of watermelon. So that's just a simple word problem. 13 is from fundamentals. It's from fraction, decimal, and percent conversion. This is building a fraction. And we build a fraction by taking the decimal that they gave us, determining how many decimal places are involved. And then however far to the right it goes, whatever the last decimal place that you can count is, would be your denominator. So in this case, we can count up to the thousandths place. So we're going to have 1,000 on the bottom. We're going to have 467 on the top, and that is C. 14 is also fundamentals, also fraction, decimal, and percentage conversion. This one goes the opposite way. So they want to know, what does 4/7 equal? Your answers are in decimals. So another way of identifying what they want is turn 4/7 into a decimal. When I take 4 divided by 7, I get 0.5714. They said round to the nearest hundredth. That's the hundredths place. That is not 5 or more. That's 1. So that rounds down to 0.57, which is A. If you have B, you round it up when there was no cause for rounding up because that's a 1. And they will always have those two answers there. They'll always make it where if you round wrong, you'll think your answer was there, you'll pick it, and you will not notice where if they didn't have that there, if they didn't have 0.58 and you rounded wrong and came out with 0.58, you would realize it because it wasn't there. So they'll always have the easiest mistake to make as the next nearest answer choice. 15 is something that we've kind of added more recently, that the TEAS has added more recently, and that's why I have, which is it's part of metric. It's part of a metric supplement. This is something they are going to give you a formula for. So I just realized I need to put the formula on here before I send this out. So you had the formula there because hopefully I'm not going to forget about this, and I'm going to redo this as soon as this is done so that the copy you receive has the formula. They will give you the formula. This is my formula that I just wrote on. The 1.8, they're not going to give you that. They're going to give you Fahrenheit equals 9/5 times Celsius plus 32. The 9/5, just like any fraction, can be turned into a decimal, and that does make using the calculator easier. So this you will have to do. This you will be given. This is the only situation where a metric equation is given. That will never happen anywhere else. This is brand new to the TEAS. They just added this on. If you're taking Hesse, they will not give you a formula for Celsius to Fahrenheit. You will have to know what the formula is. If you're doing TEAS, they just introduced this. For now, they are giving the equation. They will give it with the fraction, which does complicate it. So then you can change it to 1.8, and then you can plug your numbers in accordingly. It looks like this when I plug in the numbers. So I take the Celsius number that they gave me, and I plug that into the Celsius spot. And then I need to follow order of ops. So in this case, we have parentheses that can be added together. So we have to do that first. Then we have 1.8 times 110. And that is 198. So the Fahrenheit number that corresponds to 78 degrees Celsius is 198. 16 is from metric class, and this is an American to metric conversion. How many inches are there in 2 meters? Whenever you see a combination of like meters or centimeters, something that's metric, and then something that's American that's familiar to us, like inches, yards, or feet, you should always immediately think of this flow chart where you go yards, feet, inches, centimeters. There are 3 feet in a yard, 12 inches in a foot, and 2.5 centimeters in an inch. Make sure you're using 2.5. Not 2.54, that is technically the one that is more correct, but the TEAS has been using 2.5 to where the numbers are coming out evenly. So make sure, I don't actually remember because I have a couple of versions of the metric class, whether I told you to use 2.5 or 2.54. From now forward, always use 2.5 for centimeters. It just takes some of the complication out for you. This one is starting in metric. So this is, I guess, in my opinion, would be the harder of the two. To me, if you're starting here or here or here, it's very easy to see the flow chart in action, and it's easier to get there. This time, we're starting over here. So we have 2 meters, and that's going to need to get plugged into the flow chart to go backwards. We can't plug that in because it's meters, not centimeters. So we need centimeters. So we have to start with a 1-step metric to metric where we go from meter to centimeter. So if we have 2 meters, centimeter is a smaller unit. You should have this thought process totally down where it just comes right to your mind when you do metric. Centimeters are smaller. Because they're smaller, we need more of them to measure the same thing. And when we need more of something, we multiply. The prefix that goes with centi is 100. So this is going to cause us to do 2 times 100 equaling 200. Now we have a number of centimeters. Now we can use our flow chart. So it's a total toss-up whether you'll have to do a conversion to get there or not. But if you don't have centimeters, yards, feet, or inches as your starting point, if you don't have one of these, you will have to do something. Usually, if you don't have one of these to start with, it's because you're in metric. So you'll do a conversion. Now we can go this way. So inches are bigger, physically speaking, than centimeters. That's going to mean we need less inches to measure the same surface as we did centimeters. So we divide. So we take the 200 centimeters, we divide that by 2.5, and that gives us 80. So there are 80 inches in 2 meters. Again, if you need to see my work for longer than I'm leaving it, especially when I'm having to erase because I'm in the way of the next problem, just back the video up a few seconds and then you can pause it to see the work. 17 is percent applications. It is scenario 3. It's a little tricky because the percentage is also a decimal. So this says 0.7% of 42. So this is where you have to make sure you're fully following procedure. With normal numbers, some of you can probably just in your head switch something from a percent to a decimal without really thinking about it. When you have a weird percentage like this, you've got to think consciously about moving your decimal place 2 to the left. So as a decimal, this is 0.007. So don't shortcut and just use that. If it's got a percentage with it, it's not in the correct format. You've got to move 2 units to the left to make it a decimal. Then you can take that times 42, and that is going to give you 0.294, which is what B has. 18 is kind of another example of an average. It's from fundamentals. It's a little bit of a combo of an average and what you might think of as a regular word problem. An oven preheated from 200 degrees to 400 degrees in 5 minutes. Approximately how many degrees on average would the temperature have risen per minute? So the first thing we need to figure out is how much did the temperature actually rise, because we don't have that number. We have its starting point and its ending point. So if it went from 200 to 400 degrees, it rose by 200 degrees. So rising by 200 degrees over 5 minutes, if they want an average estimate of what each one of those 5 minutes would have had as far as temperature increase, we just divide by 5 and we get 40. And that would be C. So if it went 200 degrees in 5 minutes, it did about 40 degrees per minute. Number 19 is a proportion. This one is actually a simple proportion, but you might have thought it was difficult because you haven't seen them do it in this way yet. I put this in here because in pharmacology, when you start doing really advanced proportions for pharmacology, this is what they look like. So you're giving a patient 50 milligrams of a medication. The medication is dissolved in a solution and is available in 10 milligram per 5 milliliter doses. When you give the 50 milligrams, how many milliliters? So what we have is a situation where we have milligrams to milliliters. This is the given. So we're kind of used to the given being up here at the very beginning of the question, but it doesn't have to be. They're telling you that when you have 10 milligrams, you have 5 milliliters. So the way that they dose the medication, there is 10 milligrams dissolved in every 5 milliliters. So you have to have 10 milligrams at the same time that you have 5 milliliters. The question that they're asking is how many milliliters do you end up with if you're trying to give 50 milligrams? So I just plug 50 milligrams into my milligram spot. I put an X in my milliliter spot. I solve as a normal proportion. So I cross multiply here. I divide that and I get 25 milliliters. So if they make this medication 10 milligrams to every 5 milliliters. So remember that milliliters is liquid, milligrams is like powder. So this is powder dissolved into a liquid. They dissolve 10 milligrams into 5 milliliters of liquid. So if I need to give 50 milligrams each time that they dissolved 10, they used 5 milliliters. That means I'm going to wind up with 25 milliliters. This is just a proportion. It's just a little harder because the givens weren't up front and because they gave the given in this language. When you see per literally means over. So that tells you that it's 10 over 5, which hopefully takes you down the proportion path. 20 is a percent applications question. It is scenario 3. They just basically want to know what is 40% of 200. So you're going to take 200 times 0.4 or 0.40, and that's going to give you 80. 21 is also percent apps. This is a scenario 2. Scenario 2 is where you essentially have a statement that says, in this case, 68 is 25% of what number? So the number that they're giving us is already representing the percentage that they're giving us. So 68 is 25% of the students at this school. By taking 68 divided by 0.25, I can find out that that means there are 272 students in the school total. If 68 is 25% of them, then there are 272% of them. The way that we can check that and know for sure that that worked is by taking 68 divided by 272, and that is, in fact, 25%. 22 would be considered fundamentals. This would be considered just a general word problem. Word problems should always be a lot easier than a problem that has an actual skill like proportions or percentage, except you may feel like you have less control over the problem because it's something somewhat random that you don't have a lot of foresight into what it's going to be. This is just describing that there's 60 people going on a rafting trip. They can fit 4 people in each raft, and then they talk about how they actually carry the rafts to get somewhere. Ultimately, the question is, how many trailers do we need for this trip? So just like with the last word problem that we looked at that had several things going on, you just want to go in order, systematically figuring out why is each piece of information there? What do I need to do with it? So it really doesn't matter as far as talking about how many trailers we need to pull the rafts. We don't really care how many people we have. What we care about is how many rafts do we need given the number of people that we have. So we're going to take this 60 people and this 4 people fit per raft, and we're just going to cut the crap and say how many rafts will be going for these 60 people. 60 divided by 4 is 15. So we find out here we need 15 rafts. What they're asking us is if each trailer that they have carries 2 rafts, how many trailers do they need? So we can take the 15 rafts that we need and divide them into chunks of 2. And what we get by doing that is 7.5. So we need 7.5 trailers, just like with our bags of sugar example that we just looked at. We have 60 people going. You can only put 4 people per raft. So if I need 7.5 trailers, then I need 8 trailers, because what that basically means is you're going to have 7 trailers that have 2 rafts like they're supposed to, and you're going to have 1 trailer that's carrying 1 raft. Unless they tell you that you can do something different, you have to assume that you are stuck in the confines of the problem. They do not say anything about being able to toss a third raft onto one of the trailers that already has 2. So we have to assume that you can only put 2 rafts on each trailer. If there are 60 people, 4 people fit in a raft, and you have to transport the rafts in groups of 2, then you will have one trailer that just has 1 raft on it, and that will make it 8 trailers. You do not want to say 7 trailers, because if you do, you're going to be missing 1 raft. 7 trailers can only carry 14 rafts, and you need 15. So you're going to have 4 people that have nothing to ride on when you get there. So you want to make sure you're not trying to change parameters in a problem like this. You can't decide to put more than 4 people in a raft. You can't decide to take less than 60 people up there. You can't decide to throw a third raft on one of the trailers. So you're stuck in the confines of what they're describing. They will often have this come out uneven, like the 7.5 that we got here, to see if you notice that you're working with something that has to be rounded up. 23 is also fundamentals and also a word problem. 23 asks you to do a couple of things. One of them is to figure out what the better deal is. So you can purchase 1,000 pens for $56. You can purchase 2,000, which is obviously twice as many pens, for 106. So the first thing that I did was I said, I wonder what the difference is from the 1,000 to the 2,000. So if I bought 2 packs of 1,000 at 56 each, would it come out to 106? And it doesn't. It comes out to $112 every time you buy 2,000. So what that tells me is these 2 things have different values. The cost of each pen is less in the group of 2,000 pens than it is in the group of 1,000 pens. How many we're trying to get is 6,000. If we were trying to get 1,000, it wouldn't really matter that you could buy 2,000 for less, because we only need 1,000. If you need 6,000, there's 2 ways that you could do that. You could do 2,000 pens and do 3 packs of that. So 2,000 pens 3 times would give you 6,000 pens. Or you could do 1,000 pens 6 times, which would also give you 6,000. Since these are not the same monetary value wise, needing 6,000 pens, your best bet is going to be to buy 2,000 per package at 106 and do that 3 times. $106 times 3 is 318. So the best way to obtain these 6,000 pens is using the packages of 2,000, and you're going to totally pay $318. You might have done the 1,000 math, and if you did, what you would discover is you'd have $56 per package, and you'd have that 6 times. 56 times 6 is 336. So they not only asked you how much are you going to pay for your pens, they also asked you to determine how you should buy your pens to pay the least amount possible. As they worded it, utilizing the best available deal. Number 24, if you are still having trouble adding or dividing or subtracting mixed numbers, you definitely want to go back to that fraction and mixed number class. So I'm going to run through this very fast. What I'm going to tell you is when you add mixed numbers together, you need to put them all into improper fraction form. So never leave them mixed. Put them all into improper fractions, and then get a common denominator that's obtained by multiplying all of the denominators together. That's the only successful way to do these. So the first step is me taking each of these mixed numbers and turning it into an improper fraction instead. And that's going to lead me to have 4/3 plus 15 over 7 plus 7 over 2. that is me doing big times bottom plus top over bottom. That is the formula to get there. When I look at my three denominators now, there's nothing I can see in common between them. A 3, a 7, and a 2 do not have an obvious commonality. So what I'm going to do is take 3 times 7 times 2. You enter it in your calculator in exactly that way. 3 times 7 times 2. That is going to tell me that the best common denominator I can use is 42. So once I have my common denominator, I need to work backwards and I need to figure out how did I get there for each of these fractions. So how would I have gotten from a 3 to a 42? Remember, it always had to be by multiplication. So the question is 3 times what would have given me 42? The answer to that is 3 times 14 would have given you 42. So if I had to multiply 3 by 14 to get it there, then I need to also multiply 4 by 14, and that's 56. So 4/3 is equivalent to 56 over 42, and that brings it to our common denominator. I repeat the process here by asking 7 times what would have been 42. That would be times 6. So I do the same thing to the numerator that I did to the denominator, and that would be 90. And then the last one here, I have 2 would be multiplied by 21 in order to become a 42. And if I multiply 7 by 21, I get 147 over 42. Now I can add all my numerators together. So 56 plus 90 plus 147 is 293 over 42. That is obviously very much an improper fraction, so we want to set up a division problem like this. 42 fits into 293 6 total times. 6 times 42 is 252. You can get that part in your calculator, both of those. When I subtract, I get 41. This is my whole number, so what I have is 6 and 41 over 42. That is reduced because these two numbers are only one space apart. And that is C. Again, if you want to replay that work, you can, or if you want to pause the work and look at all of it, you can. If you're having an actual issue still with those, I would strongly recommend going back to class. This particular mock version is kind of light on fraction questions, but your real test may or may not be because it's totally luck of the draw. So you could get 3 questions like that, and it would definitely be worth making sure that you know how to do those and do them accurately and do them quickly. 25 wants to know the area of the entire court. I take this from the test because there is a question on the test that has a not so much 3-dimensional, because this one they're trying to show it to you in like a 3-dimensional kind of way where it's angled. The test has one that's just a flat rectangle, and it shows the different things that are in the basketball court and all the different things. And it looks very complicated. You look at it, especially if you took my geometry class, because if you did, you know that we do circles and half circles and this and that. All they're asking you is the area of the entire court. The entire court is a rectangle, and the measurements for the length and width of the rectangle are right there and right there. Everything else is irrelevant. They just use a picture of a basketball court to scare you. So basically what we need to do, the only other trick is they're giving us feet and meters. We need to make sure we're doing what the problem wants. The problem wants us to do the area in meters. So that's going to be 28.7 times 15.2. which gives me 436.24. The area of a rectangle is always in square units. So when you see that they just have meters, you can just completely cross those out. You know you cannot pick an area that does not have square in its answer. So the answer is going to be the one that's A, has our 436.24, but also has square meters. 26 is ratio and proportion, and this one is setting up a ratio. This one has a little bit of an extra step because they say, oh, there's 15 girls and 5 boys, but then they add some more boys to it before we actually do the ratio. So you had 5 boys and then you had another 5 boys. Now you got 10. So now you've got 15 girls and 10 boys. They want to know the new ratio of boys to girls. This is boys, this is girls. So we kind of need to swap the order that we were in. It might be tempting to think 10 to 15 is the answer, but that can be reduced down to 2 to 3, and that is choice D. 27 is also ratio. This is where we're trying to determine an equivalent ratio. So they tell you what they want you to pick what's equivalent to 2 to 3. Or another way of thinking of 2 to 3 is 2 over 3. So they're asking you which of these equals out to the same. They're basically asking you to unreduce 2 over 3. So an unreduced version of 2 over 3 is A, 4 over 6. 33 to 100 would be 1 to 3, so that's not right. 3 to 2 is obviously backwards and opposite. It looks similar, but it's facing the wrong way. And then 6 to 5 has a completely different ratio also. 28 and 29 are metric to metric. You will always get at least 2 metric to metric conversion questions. They're either 1 step or they're 2 steps. And you do the same basic process in either case. I'm going to do 29 first, then I'm going to do 28 because 29 is the easier one of the 2. So what we always do is we always determine, is it 1 step or 2? The reason I'm going to do 29 first is 29 is 1 step because we have meters there by itself. 28 is 2 steps because both of those have a prefix with them. So in the case of 29, you have millimeters to meters. You're going from millimeter to meter. The reason we're starting at millimeter is that's the one we have a number for. A meter is a bigger unit. If it's a bigger unit, you need less of them. Needing less of something will cause us to divide. We're going to divide the number that we were given by the number that goes with the 1 prefix in the problem, which is milli. Milli is always accompanied by 1,000. So 2 divided by 1,000 ends up being 0.002. So that is 1 step metric to metric. 28 is 2 step metric to metric. And in that one, we want to go from kilometers all the way to centimeters. So the first thing that we need to do is go from kilometers to meters. Then we can go from meters to centimeters. So going from kilometers to meters, we have 28 kilometers. We're going into a smaller unit. Meters are smaller than kilometers. So we need more of them, so we need to multiply. So you're going to take 28 times 1,000, which is the prefix that accompanies a kilo, and that's going to give you 28,000 meters. That's the first step. For now, we were ignoring the fact that there was even going to be a second step. Now this is the beginning of that second step. So centimeter is, again, smaller than a meter. So you're going into a smaller unit. Going into a smaller unit, you need more of them. And needing more of them, you need to multiply. So you're going to take 28,000 times the 100 that goes with centi. 28,000 times 100 turns out to be 2.8 million or 2,800,000, which is C. Again, that's fast work because by the time you reach Mach 4, hopefully you completely have that metric system down. If not, I would definitely go back to either your intense review class if you're doing intense review, or your original metric class to make sure you really have those steps down and quick. 30 is geometry. Come to think of it, we just passed a geometry question and I don't remember writing geometry. I didn't. So on 25, make sure you have geometry filled in the margin. Not that you wouldn't realize that's geometry, but I forgot that one. So 30 is also geometry. They want to know the area of a circle with a diameter of 8 meters. This one's challenging because they didn't give you a picture, so you have to remember what the names mean. A diameter is all the way across. Hopefully you remembered right away that when you're doing an area, you don't want the diameter that's all the way across. You want the radius, because the equation for area is radius squared times pi. So the radius, if the diameter is 8, then the radius is 4. So 4 squared, or 4 times 4 is 16. You can look at the answers and see that all the answers have pi still in them, so you don't actually have to multiply by 3.14 in this instance. So it's going to be C, which is 16 pi. 31 is a proportion question. I get asked about this one quite a bit, and in most cases, I just kind of recommend not going too in-depth with this problem. You could get this problem. These are not the same numbers that you would get on the actual test, but you could get a problem that quite literally has apple trees, peach trees, and pecan trees. That said, it is a maximum of 1. So if after we do this problem, you are completely confused, if you're not trying to score in the 90s, you really don't need to worry about this one question on the tiny math test. If you are trying to score in the 90s, you do need to be able to do this complicated question, and there will be a supplement class that covers these really, really tricky proportion instances. So if you don't necessarily completely have 31 down when we get done here and you need to because you need to score really high, there will be a supplement that you can do. If you don't get this down and you're wanting to score 85 and down, you do not need to worry about this. I was very hesitant to put this in to this test. I only put it into this test for those of you that need to see this, which is not a huge percentage of you. So when I write out what they have here, essentially this problem is a problem where you have a comparison that leads you to another comparison, which can then lead you to an answer. So essentially the problem here is you can't directly get to where you're wanting to be. You have to go through something else. So what I wrote out when I read through this problem is you have 4 apples to every 2 pecan trees. So unless I have a quantity of pecan trees that I know for sure, I can't find out apple trees. And then I have 16 peach trees to 10 pecan trees. And then the one piece of info, there's only one piece of info I know about the actual orchard, the actual scenario that's happening in the orchard that's being referenced here. There's only one thing I know. And that is that there are 20 pecan trees. That is the only piece of information I have that pertains to this orchard. Everything else is comparative. They're not saying there actually is 4 apple trees. They're saying at a time that there were 4 apple trees, there would also be 2 peach trees. And then they're saying if there were to be 16 peach trees, which there may or may not be, but if there were 16 peach trees, there would be 10 pecan trees at that same time. So it's all comparative. This is the one piece of information that's actually current and it's happening in this orchard. And what they're wanting you to do is go backwards. So here's your actual question. How many apple trees are there if there are 20 pecan trees? They want you to move backward knowing that there are 20 pecan trees. They want you to move backward until you find out how many apple trees that is. So when you look at the fact that pecan is the information that you have, you might notice, sorry, I don't know why I wrote pecan right here. This should say peach. So what you should have in one form or another, if you didn't write it the way I did, that's fine. 4 apples to every 2 peach trees. I had pecan written there, sorry. And then 16 peach trees to every 10 pecan. So when you see that pecan is what you have, there's only one proportion that you can see that you can relate that information to, which is the second one that they gave you. So there is a problem in the fact that what you're trying to find out is how many apple trees. There is not a direct path from pecan trees to apple trees. You have to go through peach. If I knew how many peach trees there were, I could very easily find out how many apple trees, because I have a direct comparison right here that tells me how peach trees relate to apple trees. Since I don't have a relationship that says how pecan trees relate to apple trees, I have to do this a little bit differently. So I can use this proportion because I've got pecan there and I've got pecan here. And what that would give me is it would give me a number of peach trees. If I had a number of peach trees, I would also be able to get a number of apple trees. So we're going to take 16 peach trees relates to 10 pecan trees. So this is our givens. This is what we always plug into the beginning of a proportion. And then I'm going to set that equal to 20 pecan trees, which is my actual number. What I don't know is how many peach trees would relate to having 20 pecan trees. So that's my X. Just like any regular proportion, I cross multiply and then I divide. And what I find out is that if I have 20 pecan trees, I have 32 peach trees. Now I have a number of peach trees, which can directly map me back to apple trees. So if I have 20 pecan trees, I have 32 peach trees. If I have 32 peach trees, then I can say I have 4 apple trees to every 2 peach trees. So if I have 32 peach trees, how many apple trees do I have? Again, I cross multiply and I divide, and I would find out that X equals 64. So long story, very long story made short, if I have 20 pecan trees, that means that I have 32 peach trees. And if I have 32 peach trees, then that means I have 64 apple trees. So it's a 2-step proportion. It's not something I cover in class because most people do not need to have such a complex skill set. And it's very frustrating for a lot of people. And if this problem is frustrating for you, you only need to go on worrying about it if you're trying to score really high. But it is very simple. It is very, very simple once you see what the map looks like, how you get from one place to the next. Anytime they give a question like this, it looks just like this. And you'll always basically take the same approach, which is to go and find the piece of info that's actually relevant to the real orchard and figure out how to walk backwards from that to what they want you to know using multiple proportions. The last 3 questions reference this little graph. 32 is simple. It says it's a percent app scenario 3. It says, based on the graph above, if 300 people were surveyed, how many people have French fries as their favorite food? In other words, what is 45% of 300? 45% of 300 is 135, which is C. Number 33 is just like in the advanced percent application supplement video where we did similar problems to this. This is comparative. So if 200 people were surveyed, how many more people like pizza the best than like chicken strips the best? So what we had to do was we had to go to the graph and pull the percentages down so that we could use them with the 200. So 20% like pizza. If 200 were surveyed, that means that 40 people like pizza the best. 10% of people like chicken strips the best. So if there are 200 total people, 20 like chicken strips the best, then you can just subtract them. And the question is, how many more people like pizza than chicken strips? 20 more people, because 40 like pizza and 20 like chicken strips. 34 gives us an actual number surveyed also, which is 500. And it asks us which shows an accurate number of people. There's lots of ways to do this, but there are long ways and there are short ways. So you always want to start with, is there anything that is super obvious that might allow me to get rid of something? What I notice is we have two different things that have 10%. So the number of taco and the number of chicken strips should be the same in the answers that are correct. So if I had 50 chicken strips, I should have 50 tacos. That gets rid of A because you know those two numbers are supposed to be the same. Same thing with C. And that leaves me with B and D. Just simply by saying these two have the same percentage, so they should both have the same number. That already tells us, since both of these have the same numbers there, that the first part is right. So we can start checking from this line that I just made to the right. 75 cheeseburgers versus, actually both of those are the same too, so we can keep going. So if things are the same, you can keep going until you find a difference. We're going to find a difference at the very end, it looks like. So we've got all the numbers the same until we get right here. So what we need to know is, if we surveyed 500 people and 45% like French fries, what is 45% of 500? Is it 100 or is it 225? 45% of 500 is 225. So you should get B. Like I said, there's a lot of ways to do that problem. Do not be discouraged if you have the right answer, but you don't know why I was saying to do it the way I was saying. There's lots of ways to do it. You just want to make sure that you're being essentially smarter than the problem in eliminating things that are just kind of silly, by recognizing that they're silly, by looking at them in detail. If you have two numbers that are supposed to match, if you have one number that should be very obviously bigger than another number, then you might be able to get rid of something there. Like, for example, if we look here, pizza had a much lower percentage. In fact, everything had a much lower percentage than French fries. French fries was by far the biggest percentage of any of them. So on one of these, I have the same amount for pizza as French fries, making it clear that French fries is way too small of a number to make sense for its percentage. There's a million different ways to do that. All I'm saying is go through the answer choices practically first. Look for identifying features that might allow you to say, oh, that definitely can't be it and that can't be it. Then you can start reading from left to right and doing a scenario 3 problem for each one of them. So chicken strips and tacos were 10%. So you want to say 10% of 500 is what? And that's where you find out that it's 50. If you know that both of those are supposed to be 10%, you know that those two are right. Then you can go on to cheeseburgers. That was 15%. So with cheeseburgers, you want to say, what is 15% of 500? And you'll find out it should be 75, and so on. You just don't want to start with that, because then you're trying to check all these different answers and you're getting confused, when probably a couple of them can get eliminated pretty easily to begin with. Then you can just be comparing the two that are close and finding where the difference is. In this case, we went all the way to the end before we found a difference. We made a very fast comparison till we got there. That one difference allowed us to pick the right answer. That is it for Mock Math 4. Let me know how you did here. Go back to any classes that you had trouble with, or the intense review. The intense review is updated, so it has some of the like really recent new edition type problems. So if you haven't spent a ton of time in your intense review class, that would be a good place to go and find the location of things that you're having trouble with. Hopefully you did really well here. I've been getting exceptional scores on math. Most of my students are in the mid-90s to where they're missing 1, maybe 2 questions at the most. So if you're not there, hopefully you have an identifiable area that's costing you the points so that you can fix that one area and then be there. Let me know if I can help, but definitely review back to your classes. Make sure you know the strategy, the system, the steps. That is the key to being able to execute everywhere from the easiest to the hardest type of problem in a particular category. So make sure before you walk into the test, you know the skills, the strategies, the steps. You've got them memorized. You can use them quickly. And then that allows you not to be distracted by trying to think of something like that. So if you have your strategies and your steps and everything just perfectly memorized, you're going to stop and notice things like, oh, I have to round this up because I can't have a partial trailer. Or, oh, they asked me for the total on one question, and then immediately on the next question, they asked me for the tax amount. So those little details about how they ask the question or how your answer rounds some of that silly little stuff will be more apparent to you the better you are at your strategies. That's why I give you strategies. That's why I give you review classes that are for those strategies. So if you need to get more refined on a strategy, definitely do that using your sources so that you notice all these silly little things that they try to throw in there to throw you off. So that is it for Mock 4. I will see you guys later.